For column measure mapping, the elements of this two-dimensional array are mapped on a single dimension array column by column. So I will fill these elements column by column. These elements I will take. So first column are A 0 0, 1 0 and 2 0. So first column elements are A 0 0, 1 0, 2 0. This is column index 0. Then this is column index 1. These elements. So I have finished with these elements. Now these elements. The next column A of 0 2. This is column 2. Then A of this is column 3. So the elements of a two-dimensional array are mapped column by column. Now we need a formula for obtaining an address of any element. So this address, I have taken the addresses starting from 200, and as integer, every integer takes 2 bytes. So this is 200 and 201, 202 and 203, 204 and 5, so on. Then let us call this starting address as L0, that is base address, location 0. Now let us take some example element from there and frame a formula. Suppose I want this element 1, 2. See, where is 1, 2? Here. It is in column number 2. So address of A of 1, 2. This is base address, that is 200 plus. Now for reaching this element, I should skip first column and the second column. 2 columns I should skip. So 2 into, how many elements are there in each column? 1, 2, 3. 1, 2, 3. So columns are having 3 elements. So that is equal to the number of rows, m, that is 3. So 3, then plus. Once I have skipped column 0, I am here. Then I have skipped column 1, I am here. Now from here, how much I should move? Just one element. So you can see that this is 2, 1. So this is 2, 1. And this has to be multiplied with number of elements that are W. So this will be 3 to 6 plus 1, 7 into 2, 14. So this is 214. And you can see that the index of A of 1, 2 is 214. So that's how we got the address of a given element. Now let us take one more element, that is A of 2, 2. Now let us take one more element, that is A of 1, 3. 1, 3 is here. So how to get the address of that one? So the address of A of 1, 3 is 200 plus. Now I have to skip how many columns? I should go in third column. So skip 0th column, first column and second column. So I have to skip 3 columns, and in each column how many elements are there? These are 3 elements. So this is 3 into 3 plus. Now once I reach here, how many elements I should move forward? Just one element. So this is multiplied by 2, and this is 3, 9 plus 1, 10 into 2, that is 20, 220. So 220, this is the address. Yes, 220. The element is here. This A of 1, 3 is here. So now we have 2 examples. We can prepare a formula. So let us prepare a formula for any index A of ij. This is location 0, that is base address L0, plus this is 3 and 1 or 2 and 1. See, 2, 1, 3, 1 are used. So this means first j, then I. So this is j into number of elements in a row, that is 3. Number of elements in a column, that is equal to number of rows, 3. So this is m, plus 1 is taken at the last. So this is I, that is row number. This is multiplied by W. So this is the formula for column measure representation or column measure mapping. I will write down row measure mapping formula also just below this one, so that we can see the difference between them. This was row measure formula L0 plus I into N plus J multiplied by W. So in row measure, I was used first, then J, but in column measure, J is used first, then I. So I can say that in row measure, we go from left to right, and in column measure, we go from right to left. So first j, then I. So first j, then I. In row major, first I, then j. So this is for row major and this is for column major. Now let us observe one more thing here. See, these two formulas, how many operations they are having? Plus, plus, multiply, multiply, plus, plus, multiply, multiply. So both the formulas are having same number of operations. So in terms of time, both are equally efficient. So a compiler may follow row major mapping or it may follow column major mapping. So if you are designing your own compiler, then you have option to select any one. Both are equally efficient. There is no difference in them. We can't say one formula is better than another in any situation. But C++ follows row major formula. This one, they follow row major formula. So that's all about that's all about two-dimensional array. We have discussed how row major and column major mapping is done, and we have seen the formula for index starting from 0, and also we have seen the formula for indices starting from 1 also for row major. Now for column major you can devise the formula. So you know well that only I minus 1 and j minus 1, minus 1 has to be taken. Then we get the formula for indices starting from 1 onwards. So that's all in this topic.